Have you ever stopped to wonder how your digital world stays so organized? I mean, everything from your social media feed to the files on your computer, there's this hidden system making it all possible. Today, we're prying open the Programmer's Toolkit to get a look at the fundamental building blocks of that system, data structures. So let's pull back the curtain and see how it all really works.
Think about it. Your computer might be juggling millions, maybe even billions of files. But when you hit that search bar, the one you need just pops up instantly. Now that isn't magic, it's just some incredibly clever engineering. And the secret behind that speed, the answer to that massive organizational puzzle, is exactly what we're going to break down today.
So what's the secret? Well, it's a concept called a data structure. The best way to think of it is like a digital filing cabinet or a perfectly cataloged library. It's a specific format for arranging information in a computer's memory so that we can find it and use it with maximum efficiency. It's the how behind the whole operation.
So why do we even have all these different formats? Why obsess over it? Because in the world of computers, efficiency is everything. It's the name of the game. A well-chosen data structure means your app just flies. A poor choice? It can bring even the most powerful machine to a grinding halt, wasting precious time and memory. It is all about choosing the right tool for the job.
Okay, so if we zoom out a bit, you'll see that all of these digital filing systems really fall into two main categories. Two master blueprints that decide how information is connected. And the fundamental choice is this: are we building in a straight line, or are we weaving a complex web?
In programmer speak, we call these two blueprints linear and nonlinear. And they're pretty much what they sound like. Linear structures arrange data in a sequence, one thing right after another. But nonlinear structures, well, that's where things get really interesting. Data can be connected to multiple other items, forming these intricate hierarchies and networks.
And this visual just nails the difference, doesn't it? That chain on the left, that's the heart of a linear structure. Your path is fixed. You can only go from one link to the very next one, in a set order. But the web on the right, now that's a perfect metaphor for nonlinear. From any single point, you've got multiple paths you can explore. It's all about complex relationships, not just a simple A to B sequence.
All right, first up, let's meet the straight line crew. These are the absolute workhorses of the data structure world. I guarantee you'll find them in pretty much every piece of software ever written. We're going to start with the most fundamental one, the array. An array is just like a bookshelf, where every single slot has a number. Each item lives right next to its neighbors, all in one continuous block, and this simple numbered system is what makes an array so powerful.
And this right here shows you the power of that system. Because every element has its own unique address, its index, the computer can jump directly to any item it needs. You want the thing at index 4? Bam! It's an instant lookup. You don't have to sift through items 0, 1, 2, and 3 to get there.
Okay, so if the array is a rigid bookshelf, let's contrast that with the linked list. Imagine you're on a scavenger hunt. Every clue you find doesn't just have a piece of the puzzle, it also tells you exactly where to find the next clue. That right there is how a linked list works.
We can see how it works right here in this chain. You start at the head, the first element. It holds its own data and, crucially, a pointer that leads you straight to the next element, which in turn points to the next, and so on, until the very last one points to null, which just means, hey, you've reached the end of the line.
Next up in our straight line crew is the stack. Now, this is a structure that lives by one very simple, very strict rule. Last in, first out, or LIFO, as you'll hear it called. The last thing you add is always the very first one you take out. The cafeteria tray analogy is perfect. You always grab the top tray, right? The last one that was put on the stack.
And this shows you the only two moves you're allowed to make. You push to add a new item to the very top, and you pop to remove that top item. That's it. All the action happens at one end. You can't just sneak a tray out from the middle of the stack, and it's the same deal here.
So, if the stack is all about last in, first out, the queue is its more orderly cousin. It follows a simple rule we all know from real life. First in, first out. Just like lining up for coffee, the first person to get in line is the first person to get served. Simple as that.
This slide shows you exactly how that line works. You NQ to add a new item to the back of the line, and you DQ to serve the item that's been waiting the longest, right at the front. It's a really elegant system for managing tasks in the order they showed up.
All right, so we've mastered the straight and narrow paths of the straight line crew. Now it's time to venture into the wild. Let's talk about the complex, interconnected world of the sprawling web crew.
This is where data organization gets really, really powerful.
And the undisputed king of this whole domain is the tree. Just like the name suggests, it's a structure that's all about hierarchy. It starts with a single root, and then it branches out into children, which can then have their own children. Honestly, the most perfect example is right in front of you, your computer's file and folder system.
This diagram really shows you the anatomy of a tree. See how everything starts at that single root at the top? From there, the data branches out. And that parent-child relationship is what makes trees so amazing for representing any kind of information that has a natural hierarchy, where some things are basically containers for other things.
Okay, our last structure is a true marvel of engineering, and it's designed for one thing above all else: pure speed. Meet the hash table. If a tree is about hierarchy, the hash table is all about instant retrieval. It works by taking any key, like a username, and running it through a special hash function to turn it into a number, an index in an array. This lets it jump directly to the value you want, like all your user profile data. It's the secret sauce behind those near instantaneous lookups in massive databases.
So now you're probably thinking, okay, that's a lot of different tools. How do I know which one to pick? And you know what? That is the million-dollar question for every software developer out there. The truth is, there's no perfect one-size-fits-all solution. Every single choice is a balancing act. It's all about the trade-offs.
And this table lays out those compromises perfectly. For a real light bulb moment, just look at the array versus the linked list. An array gives you that instant access, but if you try to stick a new item in the middle, you have to slowly shift every single thing after it. A linked list, on the other hand, is great at that. You just rewire a couple of pointers. But try to find something in the middle of that list, you've got to walk the entire chain, one by one. Choosing the wrong one can be the difference between a snappy app and one that makes you want to throw your phone across the room.
But here's the really cool part. You're already an expert user of all these data structures. You just might not have known it. That undo button you can't live without? That's a stack, remembering your last actions. A printer handling jobs in the order they were sent? Total queue. These aren't just abstract theories. They're literally the invisible architecture of your entire digital life.
So there you have it, a peek inside the programmer's toolkit. You now have a sense of the secret language that keeps our digital world from completely falling into chaos. You've seen the blueprints, the lines, the webs, so the only question left is, now that you know the language, what are you going to build with it?